All right, Khan Academy problem number 3. A satellite of mass m orbits the Earth at radius r and speed v0 as shown below. An aerospace engineer decides to launch an identical satellite into the same orbit around a planet that is thrice, that's 3 times, the mass of the Earth. Now, it's kind of weird to say the same orbit when it's around a different planet. So they mean the same orbital radius. So the radius of orbit doesn't change, but the planet is 3 times as massive. And they're asking, what is the speed of the satellite orbiting the more massive planet? Right. So if we increase the mass of the planet by a factor of 3, but we don't change the orbital radius, what happens to the velocity? Well, the object going around, right, is going to be much more attracted to the planet, because not because the r value changed, but because the mass changed by a factor of 3. Okay, so that's gonna greatly change the velocity. Now, I recommend memorizing this equation right here, which shows the relationship between the velocity of an orbiting object and the mass and radius of the object that it's orbiting, right? So, and this right here is your capital M, the mass of the object it's orbiting. So in this case, we have V0 based on the mass of the Earth, but what we've got now is a planet that's 3 times as massive. So if we started to write the new equation, we'd say, okay, G, and then we actually have 3me over r. And then we're trying to figure out, what happens to this value if the mass has increased by a factor of 3. So the easiest way to figure this out is by using this factor method. And what you do is you're looking for this factor right here, right? We'll call this the V factor. In other words, does it increase, does it decrease? And then you look at the factor of all the components from what it was to what it is now. Now, for the G value, right, the G value does not change at all. So that does not change. So you'd say its factor is 1, right, which means if we multiply by 1, nothing's going to change. The M factor, the mass of the planet, changed by a factor of 3. So you input a 3 there. And then the radius did not change, so that also changed by a factor of 1, meaning it did not change. So overall, we have the square root of 3 times 1 over 1, which is 3. So the factor of change for the velocity is a factor of 3. So in other words, the initial velocity, gets multiplied by a factor of radical 3 to get the new velocity. Another way to say that is the new velocity is equal to radical 3 times the initial velocity. So it was an increase of about 1.7. That's what radical 3 is about 1.7.